dRPC, one of our sponsors. I'm going to ask people to calm down now. Hold on.
1, 2, 3. OK.
Guys.
So, hello, guys. I know that you're have fun eating, but it would be nice if you can listen to me a little bit. So, yeah. So today we are on decentralized physical infrastructure conference. So I want to talk to you about this topic, like how do we distribute work in a fair way between our protocol participants? Because I'm thinking about it a lot lately, and that's been a problem for us. So I just wanted to share a few thoughts with you, and I hope there's some people who also building some other decentralized physical infrastructure projects. Maybe you will have some insights, or maybe you will have some objections, and we have some discussions afterwards. So just to say, my name is Slava, as mentioned. I'm CTO dRPC.org, and we're building decentralized RPC infrastructure for the multi-chain future. So just a few facts on like what is dRPC basically. I hope most of you, or at least some of you, heard about RPC. RPC is basically blockchain API, and we provide access to the blockchain data. But we do it in a different way from some of our centralized competitors, like maybe Alchemy or Infura. We do it just in a decentralized way, meaning that we have a permissionless pool of providers, as on the slide, and we also own centralized gateway. Basically, the job of this gateway is to distribute work between those providers. So we have this like kind of situation where we have a request from user, and we need to choose who's gonna perform it. But we, like as my topic suggests, we need to do it fair. Like let's think about what is fair, and like how do we even define it in this context. So let's start simple. I would say that fair is to distribute this across, like you should only send it to people who, or providers, protocol participants who can perform it, right? I know it's obvious and probably like can think about it themselves, but despite the fact that it's obvious, it's not necessarily simple. For example, in the decentralized RPC context, I think we are the only ones who can kind of do it, and even for us, it's a challenge. The reason is like there's a lot of different stuff, like data providers for RPC are built different. They support different blockchains, they set up the infrastructure in different locations, on different hardware, running different blockchain clients with different settings. So when you have a request, it's a really hard task to tell like whether this or that provider can perform it. But let's imagine we can do that. So then we can just do, uniformly, randomly sample one provider from the list of those who can perform the request, and just, spread it equally. It's kind of, a little bit of communism out there. But so the protocol participants are really happy if you have enough requests in your protocol. They all have their equal share of requests, and they're happy. But the clients, as like end users in communism, often, and in this case also, not really happy. And the reason is because latency is very bad. Because sometimes, for example, it's not cool when you have a request originated in Europe and you send it somewhere in Singapore, right? It's bad, latency bad, users unhappy. So let's optimize latency, yeah? It's easy. Our pipeline becomes a little bit more complicated. First, let's assume we can predict latency. So we have this request, and we have a pool of providers, and for each provider we can say like what is expected latency for each provider will be. It may seem hard, but latency actually is just like the weather. The best prediction of the weather is that the weather tomorrow will be the same as today. Same thing with latency. If you try to send request to the similar request to this provider and measure the latency, you kind of can predict that most of the times the latency will be the same. So, okay, we predicted the latency, and now we use softmax. For those who don't know what softmax is, it's very high function in AI. Everyone uses it, like neural networks, stuff like that. Basically, you can throw a bunch of numbers into this function, and get a probability distribution, where each latency, or in our case, basically provider, will be assigned a probability of getting this request. So we got this distribution, and then we do weighted random sampling. Why that? Why we even do that complicated? Why weighted random? Couldn't we just, predict latency for each provider, take the best one, and just send everything to them? Well, we want to prevent winner-takes-all situation, because otherwise we will be too much dependent on the small subset, or even one provider. And also, we want to distribute the load smoothly, because RPC is actually there's a lot of requests, and request spikes cause problems. So we want to, if the provider's latency change slightly, we want to only slightly change the request distribution, not radically. Okay, so imagine we did it, and now latency is down, and our clients are happy. But now protocol participants are crying. What happened? Well, it appears that we can classify our protocol participants as in two categories. For example, let's call them Charlie and Alice. And Charlie, he just rented the cheapest server, or bought the cheapest server close to a gateway. Remember, we in dRPC run centralized gateways. So it appears that latency, 90% of it, is actually about location, not your hardware. So it doesn't matter what you're running. If you're closer, you get better latency. So Alice, on the other hand, she spent years into investing into her infrastructure, perfecting reliability and costs. But because of that, she can't move her infrastructure closer to the gateway on the moment notice. So she is in a big disadvantage compared to Charlie. So that's what I like to call latency arbitrage. Is it fair? You could say, okay, Alice just lost, Charlie is more adaptable. He just, optimized better for our protocol, so he should win. And also, users get smaller latency. They are happy. Why should we care? Maybe we should embrace Charlies of the world. Well, the problem is that our incentives, they are set up in a way that benefits non-reliable participants. So they can spend more time optimizing latency and less time thinking about reliability. But the clients that you work with, and you can imagine a protocol where there's 100% of the participants are non-reliable. So, for example, you can have 50% of the time, most of the time, 50% of the protocol participants are down. But who cares if other 50% can actually serve the requests you have? Well, yes, but users expect you to function like your clients, not only generally, but if you have, for example, some catastrophic event, or just randomly 90% of your protocol participants go down, clients start to care because you have few hours downtime. And you have those protocol where participants are not incentivized to be reliable. So the recovery time will be huge. And you pushed out everyone who cared about reliability, because they can't wait for those catastrophic events. They need to earn money all the time because they pay for their infrastructure. So it's kind of not desirable outcome. Also, you can argue that it incentivizes providers or participants basically buy or rent servers in the same data center as your gateway, which is of course not desirable, because if this data center goes down, whole region of your service can go down. So optimizing certain metric is really unpredictable. For example, in this case, that what happened in dRPC for some time. I actually wasn't I didn't think that it will play out that way. So you should have try to think about whole picture all the time. For example, you should have a metric on decentralization, and you shouldn't invent your own. economists of the world, they spend really a lot of time thinking about this stuff. For example, there's a famous Gini coefficient, but it's a little bit hard to compute. So we used Herfindahl-Hirschman index. It's kind of an index of a monopoly on a certain market. So you can actually measure and understand, is your protocol basically dominated by one, like it's a monopoly, it's dominated by a few players, or it's really decentralized. It allows you to catch those moments when someone gains maybe an unfair advantage and tries to game the protocol. So yeah, reliability is important, for clients. So we kind of had some notion of reliability before, because we said we only send requests to those who can perform them. It means that they should be up and they should be available. But it's kind of instant reliability. It means that we do not care if they were down 2 minutes ago. And maybe we should if we want to prevent those, catastrophic events and have fast recovery. So let's say we can average error rate and uptime and have this metric of long-term reliability that we calculate, for example, on the weekly basis or month basis, depending on your needs. So then we can update our sampling formula, and it can look like that. We don't softmax only latencies, we now softmax reliability. Reliability and latency are vectors, and there's a coefficient that express importance of those properties for our protocol. So I think that this situation is a little bit more fair. Like, we now see that Alice is significantly more reliable. It has better reliability than Charlie, and we can send more requests towards her, and we now are incentivizing reliable behavior, which is great. But also, what about costs? Remember, Alice, she spent a lot of time optimizing her costs. They say that market is often fair, and you probably should have, if you build in decentralized infrastructure, you probably should have some kind of pricing auction built inside. It allows for better, efficient price discovery, give participants with optimized costs a way to compete, yada, yada. And you can also update your formula to be a little bit more complicated, but account for costs also. So this picture, in my opinion, becomes even more fair. But who am I to judge, Remember, we started, my arguments that we need to add this is basically because, clients need reliability. But why is it fair? Well, in my opinion, the only notion of fairness, actually, in this setting is, quality of service. So it's maybe obvious for a lot of you, but I don't know, wasn't obvious for me. So the only measure of fairness is whether you can have a product market fit, because if your protocol dies, nobody cares about how well participants are doing. You will be outcompeted. So I think you need to optimize for quality of service, and this is the only fairness we get. In RPC setting, the quality of service is measured by 3 things like latency, reliability, and cost. That's it. But what to do with those parameters? How to determine which is more important for us, reliability or, I don't know, latencies? You can do some reasonable defaults. You can even vote if you want, ask participants what they think. But ultimately, the best one is if you can allow users to configure them. For example, if you're building arbitrage bot, you only care about latency most of the time, and reliability, of course. But if you're building some, developer tool, you don't care about anything, just about cost. If you're, I don't know, build some monitoring or stuff like that. So if you could just, configure it in somewhere in UI or in some library settings, would be cool. So the user is actually the ultimate judge of fairness, I would say. But there is one caveat. Despite the fact that you all, I bet, build your own decentralized physical infrastructure projects, the thing is that almost always there is some centralized part of it. For example, for dRPC, it's centralized gateway. So sometimes, for example, it may be tempting to optimize those metrics I said before using this centralized components somehow. For example, using caching for on centralized gateway. And it actually optimizes latency, cost, availability, a lot of stuff. However, the problem that if you do that, who gets the money for this request? The only reasonable answer would be like entity that runs centralized part of it, like, or the protocol itself. But in that situation, the problem is that you start competing with the protocol. So Alice and Charlie, they can play games and try to outcompete each other. But if you compare them to the centralized parts of this protocol, it's not fair. It's never fair. So they don't stand any chance. So the only thing that we can stay fair is basically you should never compete with your protocol, especially if you have centralized parts in it. Because otherwise you will be incentivized to take more and more and more, and where does it stop? On the contrary, if you only take a share of what protocol's earning, for example, like a DAO or something like that, you will do everything in your ability to increase the profit of the protocol overall, and you won't be competing with your participants. So I think we should remember about that. If you want to know more about how we do it at dRPC, you can go to the documentation. We trying to thoroughly document everything and to be really transparent about it. If you want to follow us on Twitter, you can scan this QR code. And that's it. Thank you for your time. Hope that was a little bit interesting.
Yes, thank you, Slava. And do we have questions? Any